Good morning, dear students. Uh, so, last class we discussed Werner's theory. So, the next one is valence bond theory. So, bonding in coordination compounds explained by three theories. One is Werner's theory. Second one is valence bond theory, VBT, we can call it as VBT, valence bond theory, crystal field theory, CFT. So, these three theories, Werner's theory, valence, VBT, CFT, explains about the bonding and structures of the coordination compounds. Last class we discussed Werner's theory, right? Now we are going to discuss valence bond theory. Werner theory already completed, right? The next one is VBT. What are the postulates? VBT proposed by Linus Pauling. Proposed by Pauling. So, what are the postulates of VBT? First one, metal undergoes hybridization. Metal undergoes hybridization. So, what is hybridization? Mixing of valency orbitals. So, valence VBT, valence, mixing of valence orbitals to results the hybrid orbital. So, metal generally undergoes hybridization, that gives the hybrid orbital. Metal undergoes which one? Metal undergoes s orbital, p orbital plus d orbitals. Sometimes s and p orbitals, sometimes sp d orbitals mixed together to form hybrid orbitals. What is the difference between normal orbital and hybrid orbital? Normal orbitals having the different shapes, different energy, but hybrid orbitals having the same shape, same energy. So, how many mixing of normal orbital resulted the number of hybrid orbitals? That means if one s 3p orbitals, 2d orbital mixed together to form how many hybrid orbitals? 1s orbital, d2s. So, just d2 sp3, d2 sp2, right? d2 sp3 or d2 sp3. So, 1s orbital, 3p orbitals, 2d orbitals. So, how many total orbitals are mixing? 3 plus 1 plus 2, 6 orbitals are mixing. So, before mixing, those orbitals shapes are different, energies are different. After mixing all these six orbitals, the resulted orbitals are, we are calling as hybridization. You have studied in the P1 chemistry. Hybridization orbitals are 6 hybrid orbitals. How many hybrid orbitals? 6 hybrid orbitals. Six hybrid orbitals having the same energy and same shape. So once metal forms hybrid, what is the difference between normal orbital and hybrid orbital? Hybrid orbital is having the one small lobe and there is a big lobe, right? So once metal forms hybrid orbital, ligand donates the electron pair to metal atom. Ligand donates the electron pair to metal atom to form the metal and ligand bond. Metal and ligand bond. So what is the first point? First point is the metal undergoes hybridization to give the hybrid orbitals. Once that hybrid orbital forms, ligand donates the electron pair to, not electrons, electron pair to metal atom. These are empty hybrid orbitals. Metal ligand donates the electron pair to the metal atom to form the metal ligand bond. So once it forms the metal ligand bond, right? So once it forms the metal ligand bond, it gives the some geometry of the complex. Some geometry of the complex. So if the number of ligands, how many number of ligands are attached with the metal atom? What is the hybridization? Hybridization. So what is the shape? Shape or geometry? Right. The second point is once the ligand forms bond with metal atom, that gives certain shape. If the number of ligands are 4, that hybridization it may be two types. One is sp3. Generally that is what is the shape of sp3? Tetrahedral. Tetrahedral. If the same 4 number of ligands are 4, you can call it as dsp2. dsp2, that is square planar. Square planar. Right. Square planar. Right. So if the number of ligands are 5, if the number of ligands are 5, that is dsp3. Trigonal tetrahedron, generally we represent as a TD, right? So trigonal bipyramidal. Trigonal bipyramidal, generally you represent as TBP. If the ligands are 6, this number of ligand tells about the, in other words, it is a nothing but number of ligands is nothing but a coordination number. Number of ligands around the central metal atom is nothing but coordination number. If the ligands are 6, that hybridization is D2sp3 octahedral. If the ligands are 6, you can write it as a sp3d2. Both are different. This is also called as octahedral. So one is utilizing before D2sp3, the other one is sp3d2 octahedral. Octahedral generally represent OH, right? Square planar generally represent the sp. Right. So once metal forms the bond with the ligands, the based on the number of ligands, it forms the different shapes. The third point is if the metal atom utilizes, if the metal atom utilizes n-1 d orbitals, you can call it as inner orbital complex. Inner orbital complex. Inner orbital complex, IOC, inner orbital complex. So what is the meaning of inner orbital complex? What is the meaning of inner orbital complex? That is, suppose if for example 4s 4p 4s 4p, what is the n minus 1? N minus 1 d orbital is 3d orbital. These are n orbitals. This one is n minus 1 orbital. So if 3d orbital utilizes that complex, you call it as n minus 1d orbital. If the metal atom utilizes nd orbitals, nd orbitals, you can call it as which one? Outer orbital complex. Outer orbital complex. Outer orbital complex. The fourth point is compare the before forming hybridation, after formation of, compare the which one? Before formation of the complex, before forming the hybridation, hybridization, or before forming the hybridation, after forming the hybridation and bonding. In this case, if the unpaired electrons are decreased, if unpaired electrons are decreases, we are calling as low spin complex. Low spin complex, decreases, called as low spin complexes. If the unpaired electrons are increases, the second one, if unpaired electrons are increases, if the unpaired electrons are same, called as high spin complex. High spin complex. That means before forming the hybridation, right? So hybridation of, right, before forming the hybridation, that means normal electronic configuration. After forming the hybridation and bonding with the ligand, so how many unpaired electrons? If that is decreases, you can call it as low spin complexes. If it is same, you can call it as high spin complex. You will understand slowly by taking one example. The next point is, if the complex is having the unpaired electrons, you can call it as if the complex is having the unpaired electrons, you call it as paramagnetic complex. If the complex is having the paired electrons, you can call it as diamagnetic. Paired electrons, diamagnetic. Paired electrons, you can call it as diamagnetic. diamagnetic, right? So unpaired, un means the electrons are not paired. If the electrons are paired, you can call it as diamagnetic, right? In the presence of these ligands, the sixth point, in the presence of in the presence of in the presence of CO cyanide, Cn minus, in the presence of these ligands, NH3, oxalato, carbonyl, cyanoamine, oxalato. The electrons pairing takes place. Electron pairing takes place. In the presence of fluoro, chloro, bromo, in the presence of water, electron pairing does not take place. Electron pairing does not takes place. Does not takes place. Suppose in the case of D1, D2, D3, D1, D2, D3, that is titanium plus 3, D2, vanadium plus 3, D3, chromium plus 3, electron pairing does not take place. Electron pairing does not takes place. Does not takes place. In the case of D4, D5, D6, D4, D5, D6, that is chromium. You need not by heart all plus 3, plus 4, that will come based on the electronic configuration. Chromium plus 3, manganese plus 3, manganese plus 2, and iron plus 3, Fe plus 2, and cobalt plus 3. In this case, electron pairing takes place. Electron pairing takes place depend upon the ligand strength. Depend upon the which one? Electron pairing takes place. Electron pairing may takes place, may or may not takes place. That depend upon the which one? That depend upon the ligand. Electron pairing. So in this D1, D2, D3 configuration, D3 configuration never takes place the electron pairing, but in the case of D4, D5, D6, electron pairing takes place. Depend upon the ligand. Right. Brief revision of this one. Bonding in coordination compounds explained by 3 theories: Werner, Valence, VBT, CFT. What is Werner? What is valence bond theory? So valence bond theory proposed by Pauling. Metal atom undergoes hybridization. So the metal ligand bond, once the metal undergoes hybrid orbital, the ligand give the electron pair to metal atom. That is the first point. The second one is so once the ligand forms bond with metal atom, it gives the different geometries. So if the number of ligands are 4, it gives the two types. It may be sp3, it may be dsp2. Based on that one, tetrahedral, square planar. If it is 5, that is trigonal, bipyramidal, dsp3 hybridization. If it is 6, again it will give two types of hybridization, d to sp3, sp3d2. That gives the same geometry, that is octahedral. If the d comes first, you can call it as n minus 1. This is inner orbital complex. This one is outer orbital complex, right? So I can call it as outer orbital complex. Outer orbital complex. This one is inner IOC, inner orbital complex, right? So inner orbital, if d n minus 1 d orbital utilizes, you can call it as inner orbital complex. If the metal atom utilizes outer orbital, nd orbitals, you can call it as outer orbital complex. So if the unpaired electrons are decreases, you can call it as low spin. If the unpaired electrons are same, you can call it as high spin complex. If the complex having the unpaired electron, you can call it as paramagnetic. If the paired electrons, you can call it as diamagnetic. In the presence of COCN NS3 oxalate, electron pairing takes place. Fluorine, chlorine, bromine and water electron pair does not takes place. So in the D1, D2, D3 electron pairing does not takes place because there is only 1, 2, 3 are electrons only, right? So in the case of D4, D5, D6, the electron pairing takes place depend upon the ligand. These are the main postulates of VBT.